Hello students, in this video we will discuss how to solve simultaneous equation. Now understanding how to solve simultaneous equation will help us in solving mesh analysis and nodal analysis. So we will discuss about the basics of what is matrix, what is determinants, and how to use Cramer's rule. Now matrix, we have been you all are aware of matrix for a long time now. Matrix is representing numbers in array or in the form of array of in rows and columns. So this is matrix. Matrix is a numbers where you arrange them in rows and columns. So here the green color, this is called as the row number 1. So this is row 1, and here this is row number 2, and this one is called column. This is column 1, and this one is column 2. So here this A11, this green color represent the row index. So A11 means A11, A11. A11 means this one represents the row index, and this one represents the column index. So here the green color number, so this is row 1, column 1. So here this is row 1, column 2. So if you come to A21, what do you mean by A21? A21 represents the first index is always the row. So this 2 always represents the row index. So it belongs to the second row and first column of the matrix. So A21 is this element. This element is called A21. A21 means it belongs to the second row. It belongs to the second row and the first column. So whenever you write it in general, there will be two index. This green color index is for the row, and this brown color index is for the column. We call this as index. This is for the column. So the first index is for the row and the second index of the column. And this is called as subscripts. Subscripts are these numbers that you write here. So these are called subscripts. So let us take an example of a square matrix. So what do you mean by this 2 cross 2? 2 cross 2 means this matrix has 2 rows and 2 columns. So where this number of rows is equal to the number of columns, then we call that matrix as a square matrix. Number of rows is equal to number of columns. We call it as a square matrix. So here in this matrix there are 2 rows. This is row number 1 and this is row number 2. And what is column 1? So this is column 1 and this one is called column 2. So it has 2 rows and 2 columns. For example, this matrix here has 3 rows and 3 columns. So 3 rows and 3 columns. So now we are going to define something very important. What we are going to define is, what do you mean by a diagonal element? So these elements are called diagonal elements. What do you mean by diagonal elements? Diagonal elements are the elements where the row index is equal to the column index. For example, this is row 1, row 2, row 3. And this is column 1, column 2 and column 3. So what is the subscript for 9? 9 belongs to row 1 and column 1. And what about 8? 8 belongs to row 2 and column 2. You will find that the row index and the column index are the same. If they are same, then those elements are called diagonal elements. Now, other elements are called as half diagonal elements. They are not on the diagonal, they are away from the diagonal. So they are called as off diagonal elements. So in matrix you will find two kinds of elements. What are the two kinds of element? The element where the index, row index and column index are same. For example, in this matrix 3 and 4. In this matrix 3 and 4 are called diagonal elements, and 1 and 2 are called as off diagonal elements. So we have to understand this in a square matrix. Now we will come to a determinant. Now what do we mean by determinant? Determinant is a special number. We are going to, this is called as a special number, and this can be calculated only for a square matrix. So determinants can be calculated only for a square matrix. For example, if you take this matrix A, So this is called matrix A. It has 2 rows and 2 columns. So how do you find the determinant? The determinant is represented by this symbol, this letter, by this 2 box. So here what we have to do is we have to multiply these two numbers, 3 into 9, then we have to put a minus sign and we have to multiply these two numbers. So this is how we have to calculate the determinant. This operation 3 into 9 is 27 minus 4 into 6 24. So the determinant of A is 3. Now, for example, if you have a matrix called B, how do you find the determinant? Same procedure. 3 into minus 10, minus 30, minus of minus 6 into 4. What is minus 6 into 4? 24, minus 24. So, 30 plus minus 30 plus 24. So, your answer is minus 6. So if you have a 2 by 2 matrix, it's very easy. We have to multiply the diagonal elements minus the off diagonal elements. We will get the answer. So this way of doing this calculation is called as the determinant. Very important. Determinant of a matrix. Determinant, how to determine. Now if it is a 3 by 3 matrix, how do we determine the determinant? If it is a 3 by 3 matrix, what we have to do is we have to write this column one more time here. We have to reproduce this column A1, A2, A3 here, and we have to write the columns B1, B2, B3 here. So I will show you in this slide. You can see here that you get this A1, A2, A3. See here. So they have replaced this A1, A2, A3. This column is being reproduced. The first column and the second column you have to reproduce and write it here. So this is the first step. After you write it, what you have to do is we have to mark this diagonal. Can you see pink color and blue color? So what do you mean by pink color? What is the first element here? Here if you see, it is the product of these three numbers A1, B2 and C3. See the second number. What is the second number? Second number is the product of B1, C2 and A3. See the third number. What is the third number? C1, A2 and B3. It's a product of these three numbers. For these three pink color lines, we have to add them. What about the blue color lines? Blue color lines we have to subtract. So on top of these colors you will see a plus symbol. So whatever answer we get, we have to add those numbers for the pink color. For the blue color we have to subtract. So what do you mean by this? How did you get this number? You get this number by multiplying A3, B2 and C1. How did you get this number? By multiplying B3, C2 and A1. How did you get this number? You get this number by multiplying C3, A2 and B1. Remember that there is a common minus sign outside. That means we are subtracting all these numbers. Now let us evaluate for this matrix. For this matrix shown here, we will find out the determinant. So what is the first step? First step is to write this column one more time here and to write this column one more time here. Now we have to fill these 6 boxes. What is this box? How do you fill this box? It is nothing but the product of 1 into 1 into 2. So what is the product of 1 into 1 into 2? It is 2. Now how do you fill this parenthesis? What you have to do to this? We have to go to the next one. 2 into 0 into 0. So anything multiplied by 0 is 0. So how do you fill this box? How do you fill this box? Go here. 3 into minus 2, minus 6 into 4, minus 24. So here you have to write minus 24. Minus. Now we have to put minus sign. Then how do you fill this one? Multiply this. 0 into 1 into 3. So anything multiplied by 0 is 0. How do you fill this parenthesis? 4 into 0 into 1. So it is also 0. Anything multiplied by 0 is 0. So how do you fill this box? How do you fill this box? 2 into minus 2 into 2. So minus 8. So what you get? Minus 24 plus 8. So 2 minus 24 plus 8 is minus 14. So very easy. To find a determinant of a 3 by 3 matrix, only procedure that you have to remember is you have to write this column 1 one more time. You have to take this column 1 and write it. You have to take this column 1 and write it. And then you have to take the column 2 and write it. Then we have to draw lines. three lines in the forward direction like this. These three lines plus symbol, these three lines we have to write. We have to draw these three lines. Then we have to draw the other three lines. Then for all these first three brackets we have to put plus sign. For the next three brackets we have to put minus sign, and then we have to multiply those numbers and write it. You solve it one time and you will understand this one. Now the important thing is, how do we represent the equations in matrix form? For example, here I have two equations. This is equation number 1 and this is equation number 2. Now I want to represent these two equations in matrix form. Before I represent, let me tell you, this 6 is called, what is this 6? 6 is called as coefficient of I1. And what is this 4? This 4 is called the coefficient of I2 in equation 1. Same way, what is this 4? This 4 is called the coefficient of I1 in equation 2. What is this 5 called? It is called as the coefficient of I2 in equation 2. What about this 6? This 6 is called as a constant. So what is our idea here? Here we have to solve these two equations and find the value of I1 and I2. So I1 and I2 should satisfy equation 1 and 2. What is the easiest way to do this? We are going to draw three matrix. So here, when after we draw three matrix, we are going to start from this matrix. So here what you have to write? Here you have to write the variable. So here I am going to solve for I1 and I2. So first we have to write I1 and I2 in this matrix. So first we have to write I1 and I2. So always start from the second matrix. Now what about this one? This one is for equation 1. So write equation 1. So this row is going to be for equation 1. And the next row is going to be for equation 2. So you have to remember, the rows are the equation number. What about the column? The first column is for I1. The second column is for I2. So this is the idea. And what about this matrix? This matrix is for constant. This matrix is for constant. So this is how we have to, and this way it is very easy for us to understand. So this is for constant. This is for the constant. So take the first equation. What is the coefficient of I1? 6. Put it here. This is 6. Take the first equation, because now we are working with equation 1. Take the first equation. What is the coefficient of I2? It is 4. Write it here. Now what is a constant? What is a constant? This is 2. So you have to write 2. Now go to the second equation. What is the coefficient of I1? 4. Write it here. What is the coefficient of I2? 5. Write it here. What is the constant? 6. So what you have to do is, before you write in matrix form, you have to arrange the equations in the standard form. So this is called as the standard form of the equation. So you have to arrange the equation in the standard form. So this is the standard form. So this is how you represent the equation in a matrix form. So this is how you represent. So I have shown it this. So what you have to remember, if there are two equations, it will be a 2 by 2 matrix. If it is a 3 equation, you will get a 3 by 3 matrix. So where you have to start? You have to start from this row, this matrix. So this is the first thing that you have to fill. Then you have to fill this matrix. Then you have to fill this one. So you will understand this once you practice this one. So this is how you represent an equation in a matrix form. Now how do you solve this? What do you mean by solving this equation? I want to find the value of I1 and I2. So we are going to use a rule called Cramer's rule. So what is Cramer's rule? First, what we have to do is we have to find out, this is the matrix. So for this matrix, we have to find the determinant. So already we know how to find the determinant. How to find the determinant? We have to multiply these two numbers. So this is 6 into 5, 30. Then we have to put a minus sign. Then we have to multiply these two numbers. 4 into 4, 16. So your answer is 14. So this is the determinant of this matrix. Now this is the first step. Then we have to find I1. What is I1? I1 means delta I1 by delta. So here delta all of you know, because we have calculated the delta. The delta is here. So the denominator, all of you know, denominator is delta. But what we have to learn is, what do you mean by delta I1? Delta I1 means replace this constant in the first column, sorry. We have to replace this in the first column. So remove the number 6 and 4 and put it as 2 and 6. You can see here. This is 2 and 6. So this is called delta I1. So delta I1 means remove. So all of you understand, no? This is the column. This column is for I1. This column is for I2. Already I taught you in the previous slide. This column is for I2. So remove the column corresponding to I1 and replace it with the constant 2 and 6. After that, it's very simple. Find the determinant. 2 into 5, 10, minus 6 into 4, 24. So 10 minus 24 minus 40. So the answer is minus 1. See how easily we are getting the answer. Here we will not make any mistake once you understand how to calculate the determinant. Now how to calculate I2? So how do you calculate I2? I2 means delta I2 by delta. Again, the denominator is already known because here we have calculated this as 14. So denominator is known to us. But the numerator, we have to find delta I2. What do you mean by delta I2? Very simple. Replace this constant in the place of I2. So remove the column corresponding to I2 and replace it with a constant. See here, this is 2 and 6. Then we have to do the determinant. 6 into 6, 36, minus 4 into 2 is 8. So 36 minus 12 is, yeah, we have to check this one. So 6 into 6, 36 into 8. So I think we have to check this answer. Okay, anyway, this is the procedure. So let me redo this for you. I think this number should be 8. So 36 minus 8. So 36 minus 8 would be 28. So 28 by 14, our answer would be 2. So this is our answer. So I1 is minus 1 and I2 is 2. So the procedure is, we have to multiply these two numbers. 6 into 6, 36, minus 4 into 2, 8. So 36 minus 8 is 28. So 28 divided by 14, our answer is 2. So this is how you solve the problem. Now let us take a 3 by 3 matrix. Now here we have to solve this 3 matrix, solve these 3 equations, and we have to find the value of V1, V2 and V3. We have to solve this 3 equation and find the value of V1, V2 and V3. So what is the first step? We have to represent these 3 equations. So this is equation number 1, this is equation number 2, and this is equation number 3. So we have to represent this 3 equation in matrix form. So where do you start? We have to start from this matrix. So what are the variables? We have to find the value of V1. So we have to write V1, V2, V3. So this is the first step. Then what is the row? The row corresponds to equation 1. So this is for equation 1, first row. What about the second row? Second row is for equation 2. What about the third row? The third row is for equation 3. What about the column? The first column is for V1. The second column is for V2. The third column is for V3. So what about this column? This column is for constant. So let us take the first equation. What is the coefficient of V1? 1. Is there any V2 term? No V2 term. So put it as 0. What about V3? Yes, minus 2. What about the constant? Minus 1. So we have completed equation 1. So go to equation number 2. What about V1? There is no V1, so put as 0. V2, yes, 3 is the coefficient of V2. What about V3? Yes, 1 is the coefficient. What about the constant? Constant is 2. So we have completed equation 2. Go to equation 3. Yes, V1 is there, so 1. V2 is there, 2. And V3 is there, 3. And what about the constant? The constant is 0. So this is how you get the matrix. So this is the matrix, and I just discussed with you how do you get the matrix. Now go to the next. We have to find the determinant. So what do you mean by determinant? We are going to use the Cramer's rule. So this is our matrix. So this is our matrix. So from this matrix we have to find the determinant. So what we have to do, we have to column 1 and column 2 we have to write one more time. We have to write the column 1 and column 2 one more time. See here. So here the column 1, here the column 1 is written here. Take this column 2 and write it, because it is a 3 by 3 matrix. For 3 by 3 matrix we have to follow this procedure. So column 1 and column 2, write it one more time. After you write it, what we have to do, we have to fill up these, we have to calculate the determinant. We have to fill up these parentheses. How do you fill up these parentheses? How do you fill up the first parenthesis? How do you fill? We have to multiply these numbers. 3 into 3, 9. So we have to put 9. How do you fill up this parenthesis? You have to multiply these three numbers, because we are multiplying with 0, you will get it as 0. How do you get this parenthesis? You have to multiply these three numbers, because you have 0, it will become 0. One of the numbers is 0, so it will become 0. So how do you get this value of this parenthesis? So 1 into 3, 3, 3 into 2, minus 2 is minus 6. So we have to put minus 6. How do you get the value of this parenthesis? Multiply these numbers. 2 into 1 into 1. So what is 2 into 1 into 1 is 2. And how do you get this parenthesis? It is 0. Yeah, we have to multiply these three numbers. So this is how you get these numbers. So here the answer is 9 plus 0 plus 0. So I have again replaced this one for you. So the answer is 13. So the first thing in the Cramer's rule is to find the delta. After you find the delta, we can solve for V1. So what is V1? Delta V1 by delta. So what is this delta? Delta we already found out. Delta is 13. So the denominator we know. So already we have calculated the denominator. But what is delta V1? Delta V1 means replace the column corresponding to V1 with the constant. So here you see I have replaced this V1 column with the constant. So let me go back and show you. So this is the slide. So this is our matrix. So what we have done here, we have replaced this is the column corresponding to V1. This is the column corresponding to V1. We have to replace this constant in this place. So this is what we have done. So look into this one, you will get it. So this is the point. So here you can see these numbers. So we have replaced the column corresponding to V1 with a constant. And after that what we have done, we have copied this here. The first column is here. The second column is here. We are doing it to find the determinant. So now how do you find the determinant? Again we have to fill these parentheses. How do you fill these brackets or parentheses? How do you fill the first bracket? We have to multiply this column, these three numbers. So it is minus 9. How do you fill the second bracket? We have to multiply these three numbers, which is 0. How do you fill the third bracket? We have to multiply these three numbers, which is minus 8. How do you fill this one? This one. So we have to multiply this number. So it is 0. How do you fill this one? We have to multiply the next three numbers, which is minus 2. Then how do you multiply these two numbers? It will become 0. So this is how you calculate delta V1. So delta V1 is minus 15. So take that delta V1 and substitute here. So what is V1? Minus 15 by 13. So V1 is minus 1.154. So how do you do for V2? We have to repeat the same procedure, but now we have to replace the column corresponding to V2 with the constant. See here, we have replaced the column corresponding to, anyway I'll again show you this one. So this is our original matrix. Okay, this is our original matrix. So here what we are going to do is we are going to remove the column corresponding to V2 and replace that with this one. So this is the idea. So here what this you can see here, it is replaced in brown color. Now what we have to do after that, we have to replace the first column. We have to reproduce the first column here, and then we have to reproduce the second column here. Now how do you solve for V2? We have to complete these brackets. I'm not going to repeat. So all of you know how do you get this 6? 6 is product of this 1 into 2 into 3. How do you get this minus 1? Minus 1 is the product of these three numbers. How do you get it as 0? 0 is the product of these three numbers. Then how do you get minus 4 here? The minus 4 is the product of these three numbers. How do you get 0 here? The 0 is the product of these three numbers. How do you get 0 here? The 0 is again the product of these three numbers. So your answer is 9. So what is V2? Delta V2 by delta. This delta is common, denominator is common. So 9 by 13.62. So how do you do V3? So we have to replace the third column with a constant. We have to remove the column corresponding to V3 and replace it with constant. After that, again we have to reproduce the first column one more time. We have to reproduce the second column one more time. Then we have to fill 6 numbers. All of you know how to fill these 6 numbers and calculate delta V3. Now what is V3? Delta V3 by delta. What is delta V3 here? Delta V3 is minus 1. So minus 1 by 13 is 0.077. So thank you. And once you understand this, you can very easily solve problems related to mesh analysis and nodal analysis. Thank you.